Hello everyone, welcome to another video of Instrumentation Academy. In this video, we will discuss why 4 to 20 mA is used for signal transmission in a process plant. In a process plant, industrial automation is carried out by transmitting signals from field instruments and sensors to a controller like PLC, and these signals will be interpreted by the controller. Based on this received signal, the controller would issue a command signal to a final control element like a valve so that the intended process can be controlled. The input or output of a controller like PLC can be an analog or a digital signal. The analog signal can be transmitted as either a voltage signal or current signal. Usually, analog voltage signal can be 0 to 10 volt or sometimes 0 to 5 volt. And analog current signal can be typically 4 to 20 milliamperes. Since most sensors naturally generate output in the form of voltage, 0 to 10 volt and 0 to 5 volt outputs can be directly achieved. In 4 to 20 milliampere circuits, the voltage output of the sensor is sent to a transmitter which will convert the voltage signal into a current signal. The calibration of this transmitter then sets the range of current signal to be generated. When this current signal reaches the controller, they must be usually converted back into a voltage signal for processing. Now you might be thinking, why should we usually use a current signal instead of voltage signal for transmitting signals? It is because current signals have specific advantages over voltage signals. Voltage signal when transmitted over a long distance causes a voltage drop in the wires. On the other hand, current signal does not get affected with voltage drop in the wires. The measuring accuracy of the current signal transmission is far better than the voltage signal transmission. Voltage signals are highly susceptible to electrical noise and interference. Now let's discuss why we use 4 to 20 milliamperes instead of 0 to 20 milliamperes. Let's consider that a fluid passing through a pipeline exerts a pressure in the range of 0 to 10 bar. A pressure transmitter is connected which is calibrated to generate a current signal in the range of 4 to 20 milliamperes, which is proportional to the pressure being exerted by the fluid on the pressure sensor. This pressure transmitter is connected to input card of a PLC. When there is no fluid flowing through the pipeline, no pressure is exerted on the sensor. But the pressure transmitter still generates 4 milliampere current signal at the output terminal. If the pressure exerted on the sensor is at its maximum calibrated value of 10 bar, the transmitter generates 20 milliampere current signal at the output terminals. So, if no current flows through the wire between the transmitter output terminals and the input card of the controller, it can be concluded that there is a break in the wire connected between the transmitter output terminal and input card of the controller. Now consider the other case that fluid passing through the pipeline exerts pressure in the range of 0 to 10 bar and the transmitter is calibrated to generate current signal in the range of 0 to 20 milliamperes. When there is no fluid flowing through the pipeline, the transmitter generates 0 milliampere current at the output terminals. In this case, it would be extremely difficult to identify that either 0 milliampere current is due to the wire break of the transmitter or it is due to no pressure of the fluid. Hence, if the transmitter is calibrated to generate current signal in the range of 4 to 20 milliamperes, the faults like wire breaks can be easily detected. But this reason is a secondary reason for the widespread use of 4 to 20 milliampere signal. The primary reason that 4 to 20 milliampere is used instead of 0 to 20 milliampere is because it allows to power the field devices on the same two wires that is used for transmitting signals. While using 4 to 20 milliampere current signal, since there will be at least 4 milliampere flowing through the loop, the connected instrument can be powered using the same two wires that transmit signals. Process control devices such as digital displays that take advantage of this principle to power itself using the 4 to 20 milliampere loop is called loop powered device. Loop-powered instruments consume very little power in order to be able to operate with the power supplied to the loop. A two-wire connection may not be able to power devices that require a large power to operate. So, a 3-wire or 4-wire connections are used to connect an external power supply for devices that require large power to operate. By this, we come to the end of this video. If you like the video, please support us by subscribing our channel. Thank you.